Here's a solution for day 4, problem 1. Sketch the graph of f of x equals the cosine of x, and hint, use the unit circle diagram. By using the unit circle, we can find values of cosine for different angles without having to use a calculator to give us those values. Notice on the grid that we're going to graph that on the x-axis, this is pi, and this is 2 pi units. And going to the left, this is negative pi, and this is negative 2 pi. On the f of x axis, this is 1, this is negative 1. A cosine function is going to create a wave-like picture. We can find that wave by plotting some points and then drawing a line through them. Let's start by figuring out the cosine of 0. Using the unit circle, finding 0 on the unit circle, and then looking at the x-coordinate of that point, we see that the cosine of 0 is 1. Next, let's find the cosine of pi over 2. Pi over 2 on the unit circle is at the very top of the unit circle. Pi over 2 radians corresponds to a 90-degree angle. No doubt you're more familiar with angles measured in degrees. And the x-coordinate of that dot at the top of the unit circle is 0. So the cosine of pi over 2 radians is equal to 0, and that dot is right here. The cosine of pi is negative 1. This spot here is 3 pi over 2, and looking at the unit circle, that spot ends up at 0. And finally, the cosine of 2 pi is 1. Here we have one period of the wave function. And we can connect these with a smooth curve. Kind of round it out as you get to the bottom. You don't want to create a V shape. It needs to be more rounded, kind of like little like hump-like things. Okay, we could keep going to the right, but we're out of space to the right, but we can replicate this going to the left. So if we find this spot right here, that function is going to go down and cross through there, and then right under pi, go down here to negative 1, and the function will come down and then start to curve back up there. And then let's find that spot right there, and the function will curve up through that spot. And then finally at negative 2 pi, the dot would be back up there at the top of a peak of the graph. And it would continue to the left as well forever. So we get this wave-like picture as the graph of cosine of x. Day 4, problem 2. Find the sum of the first 100 terms of this arithmetic sequence. 3, 13, 23, 33, etc. Hint, here is a formula that will find us the sum of terms for an arithmetic sequence. We want to find the sum of 100 terms. That's what the S with the sub 100 means. And so we're letting n be 100. So let's substitute that in to the formula. A sub 1 refers to the first term in the sequence, which we can visually see is 3, plus, and then A sub n, where n is 100, is the 100th term in the sequence. We don't currently know what the 100th term is, so we need to find the 100th term. To do that, let's first find a formula that will figure out any term that we want. So we're going to use A sub n to represent a general term of this arithmetic sequence. What's the common difference between terms? It's 10. You add 10 every time. The rate of change is 10. And so we can go 10 times n, where n represents which term we're interested in finding. And then there might need to be an adjustment on the end. Let's figure out if we need to have an adjustment. For the first term, we would use 1 for n. 10 times 1 is 10. But the first term isn't actually 10, it's only 3. We would have to subtract 7 to compensate. Now just as a check, let's make sure that works for the second term. 10 times 2 is 20, and 20 subtract 7 is 13. So when n is 2, this outputs 13. Yup, that is what the second term is. So this linear equation is the correct equation that finds any term that we're interested in. Well, we want to know the 100th term. What's a 100? So 10 times 100 subtract 7. 10 times 100 is 1,000. Subtract 7 is 993. Now we know what this number is right there. It's 993. So for our sum, 100 divided by 2 is 50. And 3 plus 993 is 996. If we multiply these together, we will have the sum of the first 100 terms in that pattern of numbers. The answer is 49,800.